how's it going? I know that quarantine can be a pretty scary and really boring time for all of us. So what I've been doing to get through that is try new hobbies. One of those hobbies has been skateboarding. Skateboarding is really fun. I really like it. I can skateboard with my friends. I can do all kinds of stuff. But for you kiddos out there, you should be wearing your elbow pads, your knee pads, and a helmet, because if you don't, you could end up like me doing stuff like this. That's why it's important to have parental supervision when you skate, so when accidents like those happen, they can be there to make sure everything is okay. When accidents like those do happen, you might get some cuts and bruises because you're not wearing your protection that I mentioned earlier. And your parents might go and grab hydrogen peroxide to clean out your wounds. And you're probably wondering what that is. Why don't you follow me and I'll show you. So this here is hydrogen peroxide, and the way that hydrogen peroxide works is it undergoes an oxidation reduction reaction and it forms bubbles, and when those bubbles are applied to your wound, it helps pick up debris and extra dirt that may have gone in there, as well as cleans up the bacteria that can get in there and cause an infection, and it's all gross and there's pus and it's just nasty. You don't want to do that. Now, you may not know what an oxidation reduction reaction is, so let me further explain that part. Here's the detailed explanation on oxidation reduction reactions. Oxidation reduction reactions are the transfer of electrons between two compounds in a reaction. Oxidation stands for the loss of electrons, while reduction is the gain of electrons. One way that people memorize this is by the acronym oil rig. The oil in oil rig stands for oxidation is loss, while the rig in oil rig stands for reduction is gain. This is an easy way to remember which compound is being stated as the reduced or oxidized species in the reaction. Now, when it comes to these reactions, there are rules to how each element receives its oxidation state. Oxidation states are the number of electrons per element or compound. For elements by themselves, it is 0. For example, we have hydrogen by itself, oxygen by itself. Really, any element that stands alone, its oxidation state is 0. For monatomic ions, we have oxygen as -2 or -1 in hydrogen peroxide. Fluorine is -1, and hydrogen is +1 with nonmetals and -1 with metals. For the other species in the periodic table, for group 1A, which is here, it's +1. For group 2A, which is here, it's +2. And for halogens, it's -1, but positive with oxygen, and those are here. Now there are rules to how we apply the oxidation states to each compound. The sum of oxidation numbers for a neutral compound is 0. For example, we have ammonia. The oxidation state of hydrogen in this case would be +1, as we saw before. +1 multiplied by 3, which is how many hydrogens are in this compound, is 3. So, the oxidation state of nitrogen would have to be -3 to equal 0. As we can see here, -3 plus 3 equals 0. Now, for polyatomic compounds, the sum of oxidation numbers for a polyatomic compound is its overall charge. So, as we see here, nitrate, its overall charge is -1. So since this ion has a negative charge, the overall oxidation number will be -1. This means that nitrogen would have an oxidation state of +3. This is because oxygen has an oxidation state of -2. -2 times 2 equals -4. +3 plus -4 equals -1. We can also see that here. So when we look at hydrogen peroxide, we see here we have hydrogen peroxide on the left, which is the reactant, and we have water and oxygen as the products. Looking at the oxidation state of oxygen, we can see that in hydrogen peroxide it's -1, in water it's -2, and when it's just oxygen alone it's 0. Now, the cool thing about hydrogen peroxide is the electrons are being transferred simultaneously. From hydrogen peroxide to water, an electron is being transferred and water is gaining an electron. But from oxygen to hydrogen peroxide is gaining the electron. So as you can see, it's going back and forth, which is really cool and doesn't happen typically in oxidation reduction reactions. So if we wanted to put this in words, what's being oxidized is hydrogen peroxide because it lost an electron to water. But also, oxygen is also oxidized because it lost an electron to hydrogen peroxide. What's being reduced is water because it gained an electron, but also hydrogen peroxide is reduced because it gained an electron from oxygen. So this is how oxidation reduction reactions work, specifically with hydrogen peroxide. Oxidation, that's why you need to have parental supervision when doing this. Oxidation reduction reactions actually happen all around us. It happens in photosynthesis, cellular respiration, which is just how we get our energy in order to do things like skate. Our batteries, when you make a fire to make s'mores or burn stuff, which you should also have parental supervision for, it's all around us, and this burns. And it's actually really cool. Alright, now we're just gonna apply the Band-Aid. Put that where my clean wound is because of hydrogen peroxide. And now, I'm ready to, I'm ready to hit the road. And I'm a little more prepared than I was last time. Alright kids, last 3 things I'll tell you. 1, science is cool. Number 2, listen to your parents. And number 3, skating is fun.